Okay, so the next example is the cutting stock problem from page 529. And what we have here is basically we have some kind of rolls of raw metal. And each of these rolls of raw metal, we can actually produce products out of it. And our products are 12-inch rolls, 15-inch rolls, and 30-inch rolls. And they don't fit, you can't fit completely. So in each pattern, there is a degree of scrap. So this one here, pattern 4, has the lowest scrap, I guess mostly because it's producing very small rows that fit together. And for example, some of these patterns 5 and 6 create a lot more scrap. We have a certain demand that we need to actually fulfill. And basically what we're trying to do is we're trying to meet this demand. So if we look here, these are the demand equations. Basically, so for 12-inch rolls, we need we get 0 from pattern 1, 0 from pattern 2, 1 from pattern 3, 9 from 4, 2 from 5, and 7 from 6. And basically we multiply those coefficients by the number of rolls of each pattern, and it's got to be greater than or equal to 500. And our optimization criterion is we're just trying to minimize the amount of scrap. So we're trying to fill this demand while minimizing this amount of scrap. And these are our decision variables here. These are the number of rolls, and these rolls are actually going to be integer variables. But we will play around. We'll do a non-integer solution first, and then we'll do an integer solution. Okay, so basically the number of 12-inch rolls produced, it's each of these patterns multiplied by the number of rolls for the pattern. So that's going to be number of rolls times the coefficients for the 12-inch rolls. Now I'm actually going to move these. I'm going to control R to get the 15 and 30-inch rolls. So I'm going to put $1 on the B so it doesn't change when I move to the right. So, and I'm going to go Control R. And you see here I still have my number of rolls, but this time I multiply it by the 15-inch, and this time I multiply it by the 30-inch. And we want to minimize, again, sum product, number of rolls with the amount of scrap. Beautiful. And so we've done our constraint, so we've done the scrap. So let's just kind of run the solver. So we're going to do data solver, and we're going to, let's just do this from scratch. This is going to be a minimum of that, minimum beat the scrap by changing these subjects to constraints. So we're going to add these constraints. These rolls produced must be greater or equal to the demand. And we're going to do a non-integer first and see what we get, and then we're going to do the integer solution. So I'm going to click solve. And we get 1,521 scrap, but you see we have partial rolls here, which isn't a real solution. I guess we could round these, but we still wouldn't be guaranteed to be a feasible solution. We could play around with this solution to get a decent answer, but let's go back to solver and let's just see. Oh, we should have used the simplex. Let's do the simplex again. But we get exactly the same. We get exactly the same result because it's a relatively equal problem. Okay, and what we're going to do is we're going to add some constraints. And these are going to be integer. And we're going to do exactly as before, but with integer constraints, and click solve. And you see we now have integers. So we've gone up from scrap 1521 to 1527 because we can't kind of cheat by having a partial number of rows. So we're going to cut 72 from pattern 1, 211 from pattern 2, and 56 from pattern 4. So we actually managed to succeed without using any of these patterns that create a lot of scrap. And you see this is kind of our binding constraint, because we're doing integer solutions to things like the shadow prices and stuff. We talked about reduced costs are not quite as important. We won't go through those, but you can see here that we have 715. So this is like the binding constraint, and we also have we go over on the 12-inch rolls and over on the 30-inch rolls. Though we will actually. Let me just solve. And again, because it's integer, you see we don't have the sensitivity reports, but we can just see here, we can actually see we can get the answer report, and we get the results from it. We can see which constraint is binding, and it's the 15-inch constraint is the binding constraint. Okay, so I won't add all these in this time. I'll try and make this read, not having too many sheets in the worksheet, and that is the cutting style problem.